Okay, hello everyone. This is Mr. Morrissey, Bedford High School, and today we're going to be doing a review of solving linear systems, and we're going to do 4 problems together. And here we go. So the first one is using substitution method, solve the system 2x plus y equals 1 and negative 3x plus 2y equals 9. So with substitution, looks like I'm going to isolate the y. So I get y equals negative 2x plus 1. And I'm going to plug in the equation y equals negative 2x plus 1 into the second equation, so into this one right here. And so I've just made the substitution. And now let's see, let's distribute real quick. Once I subtract 2 from both sides, it looks like I get x is negative 1. And let's see, we want to solve for x and y. So I always say to my class, let's plug into the easier looking equation. So let's see, how can I do this? I think this one that I highlighted seems a little bit harder. It's got a negative on it, and it's got bigger numbers, 3, 2, and 9. So I am going to be plugging into the first equation. So let's see, when I add negative 2, when I get rid of the negative 2, I'm going to get 3. So it looks like my solution is negative 1 comma 3. And so there's my first answer, negative 1 comma 3. And I could test that by plugging in negative 1 comma 3 into both equations. Let's plug it into the highlighted more difficult equation. So you should check both, but just in terms of time, let's just check one. So this is 3 plus 6, that's 9. That checks out. Cool. Okay, so that's solving substitution method, solving a linear system. Remember, you can pause the video at any time. We're going to go to question number 2, solving, let's see, use the elimination method to solve the system. Okay, I noticed that, let's see, a couple things I noticed. Hold on. I'm not going to deal with the 3y and 2y because I'd have to multiply by 2 different numbers to eliminate them. But I'm going to multiply here. Whoops, let's erase that. I want to multiply by negative 2. So let me rewrite the first equation. There's my first equation. Now I'm going to multiply the second equation by negative 2. Okay? So there's my second equation. And I'm going to add the 2 equations together. Y looks like it's equal to negative 2. So again, like in question number 1, I'm going to plug y equals negative 2 into the easier equation. I'm going to call that the second equation. Remember that 2 negatives multiplied together are a positive. So it seems like x is equal to 1. So my answer is 1 comma negative 2. And again, let's just do a check of this answer. So let's see. That's negative 4. That works. And the second one, that's 5. That works. Nice. All right. So we just did a substitution and then an elimination problem. And now we're going to move on to questions 3 and 4, which we're going to not assign, and there's not going to be a certain way to do them. So again, we're doing solving linear systems. This is Mr. Morrissey from Bedford High School. And let's see, I'm looking at this. I personally prefer elimination. So let me go out of my comfort zone and let me do substitution. So I'm solving for x, and let's see. Okay. It looks like 6 equals 7. In my book, I don't think that's true. So this is going to be an example of a no solution. And let me give you an idea of what that looks like. So these are two equations of lines. So something that has no solution possibly are two lines that have the same slope but different y-intercept. Sorry, this is a little hard to read. So different y-intercept. And just real quick, since we're on the topic, why don't we just show that this is true? So taking this equation, we're going to get, negative 2y equals negative x plus 3. There's the first equation. And then the second equation, we're also going to solve for y. I feel like I did this one wrong, so I better check this again. Negative 2y is negative x plus 3. Divide by negative 2, this is a positive, that's a negative. Yeah, that's right. Okay, now the second equation, let's see. Okay, so it was what we said down here with the same slope. Let me highlight that for you. The same slope, different y-intercept. You notice the slope here is a half, the slope here is a positive half, but the y-intercepts are different. Okay, so the answer for this one was no solution. Let me do something I think Mr. McGowan taught me, or actually my students taught me that they said Mr. McGowan does. Whoa, cool, look at that. No solution. Okay, let's do one more. So next one, solve the system. Let's do, whatchamacallit, let's do elimination. So, can't erase that real quick, can't really see it. So let's multiply by negative 2. Whoa, what's going on here? That's not good. Okay. Whoa, okay, everything's disappearing. Do you guys see it's like, whoa. Okay, so that's like Harry Potter. So let's do this again. Whoa. Okay, start over. Okay. Let's try a different color. A little Harry Potter action there. So let's multiply by negative 2. Okay. Sorry, this was going so well. So negative 2x. So we're going to add. We're going to add the two equations. 0 equals 0. That's true. Unlike the problem at the top here where 6 equals 7. So 0 equals 0 is true. So this is going to be an infinite solution. And what that means is that the lines are actually overlapping. They're the same line. So let's show that that's true, and then we'll be done. So we'll solve the first equation for y. There's the first equation. Now I hope the second equation is the same one. Hey, a quick little technique I would point out that I think is something that you should recognize is that if I highlight, notice that all those the four coefficients there, the four numbers, are all divisible by 2. So I would immediately divide all of those numbers by 2 and get, let's say, x. Oh, actually, we're done. Look, this equation here, x minus 2y equals 4, is what you started with. So you know you have the same equation. They're overlapping. And we're done. So as a quick review, we had, let's see, we had a substitution method. We had an elimination method. And then I went out of my comfort zone and did a substitution method, which was a no solution. And then we finished with a elimination method, and we found we had infinite solution. I hope everyone's enjoyed this screencast, and I bid you adieu. Bye-bye.